Hello, Assalamu alaikum. Today we're going to talk about our DLD project considering the Flappy Bird or Flap GA dodging game which we have created using our FPGA board. In this rendition, players control a hero block as they navigate through a series of obstacles and challenges in a side-scrolling environment. The game logic is quite simple. The players guide the hero block through a horizontally scrolling world, avoiding obstacles, and the objective is to travel and challenge yourself to reach 30 points without colliding with any of the obstacles. If in this game the hero not only goes up like in a traditional Flappy Bird game, we can also go down. So the logic is as that we create the effect of gravity, and several counters are used. When we press the up button, we give the hero an upgoing velocity by setting the movement counter to a small value and the hero status to jumping up. And when the counter decreases to 0, we move the hero up by a few pixels and assign a greater value to the movement. The opposite happens when we press the down button, as the hero will go down a few pixels and the hero will keep falling down until the up button is pressed. So we're gonna play the game to give a certain visual.
So now we're going to play the game, we're going to demonstrate it what happens. So it's normal, you have to navigate it through. If you collide, you reset and you have to start all over again. As soon as this counter, which is on our FPGA board on the 7-segment display, hits 30, the game will stop, meaning you have reached the 30-second limit and you would have to reset it. Now we have reached 30 seconds.
Which we will show further on.
Now we're going to demonstrate what happens on the FPGA board when we're playing the game. As you can see, the 7-segment display increases by 2 for the time the game is running. As soon as this figure hits 30, the game will reset. We have at 30, the score has now reset. These 3 lights over here will indicate whether we have hit the score 30 or not. Now, as soon as I press the reset button, we go into a reset state. These 3 lights indicate the game is in a reset state.
And when we do start the game, these are the 2 lights that indicate the up and down buttons, which are either the W or S button or the space and enter button, which the user can play according to their liking.
So for our FSM state diagram, the first state that we would have would be the start state, in which the screen would be idle, there would be a hero block and there would be some pipes. They won't be moving at this time. But if you press W, then we will be switching to the up state, in which the hero block would be going up until you press the S switch, in which the hero block would start going down. During our game, we would be switching between the up and down state and the game will be running. On pressing the X button, the game will reset and we will go back to our start state.
A user flow diagram of our project. The user flow diagram is elegantly made, indicating all the possibilities for a user in this game. The user is controlling any of the W or space keys to move up, or the S and enter keys to move down, which we can see in our moving on from our initial stage to the press buttons for movement and the 2 options going there. So if we intercept with the pipe, the user flow diagram will move back to the initial stage or keep moving down. And as explained before, if we press X, we would reset the game completely and go back to our initial stage or our start stage. The user can either move up or down and keep moving until they reach 30, the score of 30, at which the game will also pause or restart completely. So if it does not reach the score of 30, it would keep moving as we see here, or in the other case, the game would end and you would be completing our challenge. So that would be our user state diagram, user flow diagram.